Hello everyone, I'm Kunyang and I'm going to present my final project, How to Win the Game in League of the Legends. I divide my presentation to 6 parts as the slide shows. So the first one is introduction. I will talk about some basic settings of the game and basic information of my datasets and also the problem I defined. League of the Legends is a free 5v5 online mobile game created and published by Riot Games. The end-game objective of the game is to destroy the enemy team's next located deep into their base. Players split into rows and hide into lines where they must kill minions for gold, battle enemy players, and destroy their structures. There is also a jungle with a wide variety of jungle monsters as well as natural monsters that can be killed for both teams, such as Baron Nashor, Elemental Drags, or Elder Drag. The killing of these monsters grants different bonus and rewards. The dataset I use is from Kaggle. This dataset contains the first 10 minutes detailed data of approximate 10,000 ranked game from a high level. So players are roughly having the same gaming technique. There are total 21 columns and 9,879 rows in it, and all about the blue team. I will explore them more in the future sector. The purpose of the players playing this game is to win, and this is a typical classification problem because the final result of the game is win or loss. Besides, League of the Legends is one of the most popular computer games in the world, which means there are a huge amount of players need a suggestion. Which factors influence the results of the game? Okay, so let's take a look at our data. After importing the data to pandas data frame, I use dtabs function to find the basic information of the data, and from the data info command, it seems like there are 8 categorical columns and 13 numerical columns. I explore every columns and I will just present 3 typical columns here. The first one is blue total gold, which is a categorical attribute which has 5 categories: normal, few, many, very few, and very many. The second is the target column, blue wins, and of course it just have yes or no. The third one is blue word place column, and this is a numerical column. We can see some basic information of it. For exploratory data analysis, I found a very useful package, Pandas Profiling. It's an open source Python module with which we can quickly do an exploratory data analysis from a HTML report with just a few lines of code. So let's take a look at the reports. Okay, use blue word placed as an example. When I click toggle details, it will show a very detailed information like minimum, maximum, and range, and a lot of useful index. And it also have a histogram like this. The most common values and the extreme values, minimum as the maximum. And it also do the correlation and misuse values research in the end of the report here and here. So I think it's very powerful. I think it's very powerful to explore the data. Okay. So about the next part, data pre-processing and preparation. After checking, the dataset has a very good condition that there are no missing values and duplicated values. And for the first column, game ID has no relationship with the results, so I decide to delete this column. And based on the reports, there are no outliers for all numerical columns except this, the blue word placed column. Okay, so for it, low records can be existing, but too many can't, and that's all because the facts of the game. So I decide to delete the records which above 99 percentile. Okay, the last step is transformation, which is converting all the categorical columns to the numerical columns. And what I use is map function like this. Okay. Next, machine learning and statistical modeling, and this is the most important part of the whole project. The first step is creating training and testing data, and it's also quite easy using train test split module method from sklearn mode selection to automatically split the original data sets, and the code is also here. It's very simple. For supervised learning algorithm, I used naive Bayes, decision tree, random forest, logistic regression, and k-nearest neighbors. The module that all the algorithms are implemented is sklearn. Here is an example, and I also calculate the accuracy for each algorithm using accuracy circle and the sklearn matrix. Actually, the code is quite simple here. For unsupervised learning, input data is now labeled and doesn't have a known result. So the algorithm I choose is k-means, and I also set clusters as true. What I want to archive is that it will be divided to win and loss group. So the accurate for testing results is about 28%. But what I think is that it just divided to two groups but doesn't labeling them. In other words, the accurate is 72%, and this result really surprised me. Next part is mode performance evaluation and algorithm fine-tuning. As I said before, I calculate the accuracy for each algorithm and I create a table to show it. We can find that the logistic regression is the most accurate. So for the next step of fine-tuning, I will only choose logistic regression to move forward. The method I use for algorithm fine-tuning is grid search CV and sklearn mode selection. Grid search CV search over specific parameters values for an examiner. I set two parameters for turning. The first one is dual, true or false, and the second one is max attire. 100 and 150, 200, 500, and 1000. After training, I found out the best parameter is dual equal false, max attire equal 100, and the accuracy is about 73%. So for the last part, mode interception, we can find out that the blue dragon has the most positive correlation, and the blue herald has the most negative correlation. Which means if you want to win the match, you must control as many dragons and lice heralds as you can. Besides, the first blood, elite monster, and jungle minions killed are also very helpful to win the game, and you need to avoid getting lots of experience for the whole team. So that's all. Thank you very much. That's all my presentation.